Alright, so this weekend we're going to look at limits. Instead of going to a number, a specific x, we're going to look at what happens when we look more towards the end behavior. So as x gets to infinity and negative infinity. This is where asymptotes will come into play, because as we go, x gets larger, we sometimes hit an asymptote, which means we're stuck at a certain number for infinity. Other times we'll look to see what's happening as well in some other situations. So first thing I want to look at is just your basic, what happens when we go all the way to infinity for x for the equation 1 over x. So if we sketch the graph, because sometimes that does help, we do have an asymptote, because since x cannot equal 0, we're going to have an asymptote on our y-axis, which means our graph ends up looking something like this. Because again, x can also never equal 0, meaning we'll never get a y equals 0. So what we're going to look at is what's happening as x goes to infinity and negative infinity. Well, because there's an asymptote on the x-axis, that means our graph is going to get infinitely close to 0 even though it never touches. And it will never touch 0, but we say the limit is 0 because it's going to keep getting closer and closer, smaller and smaller and smaller, until it almost looks like it does, even though we know because there's an asymptote it really doesn't. And that brings us to one of our rules for limits to infinity. So you can put a little star here. Any number divided by infinity. So if you thought about direct substitution, we can't really substitute infinity, but we can substitute larger and larger numbers. If we were to plug in 1 over 100, 1 over 1,000, 1 over 1,000,000, you're still getting closer and closer to 0. So whenever you end up with infinity in the denominator, the limit as x goes to infinity will equal 0. Okay, so this is one of our main ideas that we like to use. And how we like to use it is that if we have a limit to infinity, if we can get an x in the bottom, then we can use this idea. Because by direct substitution, we'd have infinity in the bottom, which means would equal 0. So if we look at number 2, if we were to plug in larger and larger numbers for x, so thinking of direct substitution like we did yesterday, we'd have infinity squared. Well, infinity squared is just infinity times infinity, which is a bigger infinity. So this is even if it's squared, we can still say that it's going to equal to 0 because of this same rule. So whenever, again, we have limits to infinity, we want to try to get our x in the bottom so that we can make things go to 0. Okay, so if we look at number 3, we do have an x in the bottom here, but it's not by itself, and that's where we have an issue. So we wouldn't be necessarily going to infinity because we have another number. So we can only have it equal 0 if there's only an x in the bottom. So one of the things that we're going to do, one of our methods here that we're going to do to help us be able to use that first one, is you're going to divide everything by the highest power of x. then do the limit. So this is one of our methods we use if we don't have just x in the bottom. So if we look at number 3, our highest power of x is x to the first. So I'm going to take everything here and divide it by x. And as long as I do it to everything, we're keeping the equation the same. So I am going to simplify a little bit before we do the limit, because on top I'll have x over x, that's 2, plus 5 over x, and I'll have 6 over x minus 1. So now if I go back to that first idea right here, what would 5 over x be if we take the limit as x goes to infinity? This would all just become 0. So I have 2, because there's no variable there, so I can't really change it, but the 5 over x will become a 0. The limit of 6 over x, because x is in the bottom, will become 0, and I still have my minus 1. So no matter, the reason we don't have to do the 2 and the negative 1 is because there's no variable there. There's nowhere to substitute x. So we're only doing the 0 for the ones that have x in the denominator. So if we keep going, 2 plus 0 is 2. 0 minus 1 is negative 1. So our limit would be negative 2. Okay, so again, this is using this idea that if we divide everything by the highest power of x, then we'll get all of these little fractions with x in the denominator that we could do a 0, turn to zeros because of the limit going to infinity. Okay, so let's look at number 4. This will be the last one for tonight, and then we'll do a couple more in class just to make sure we're okay with this idea. So start it the same way, the highest power of x. So our highest power of x is x squared. So I'm going to divide everything by x squared. And I am going to simplify where I can. So this will become 1 over x on top. On bottom I'll have 1 plus 5 over x squared. And then I'll do my limit. So if I take the limit of 1 over x, that'll go to 0. On the bottom I'll have my 1. I take the limit of 5 over x squared. It goes to 0, and I get 0 over 1. Because 0 is on top, we would just say our answer is 0, or our limit as x goes to infinity is just 0. Okay, limits again are something that's going to follow us through this unit, and they follow you through calculus, because limits are one of the core ideas of calculus. And there's a lot more little tricks and rules to limits, some of which we're going to learn now, some of which you have to wait and learn in calculus AB. So some of it you'll learn next year in AB. My favorite is L'Hôpital, just because it's a fun thing to say. But it's another kind of trick, and that one works specifically with infinity. So for right now, though, we're just going to stick with these two main ideas, that anytime we have a number divided by infinity, our limit will equal 0. And we're using that to help us find limits. So we're going to divide everything by the highest power of x to help us get that 0 and that x in the denominator, so that we get our limit of 1 over infinity to make it 0. So like I said, we're going to do a couple more in class, 3 more to be specific, just to make sure we've got it. But this will be all we're going to do on Monday. So if there's any questions or points of confusion, please make sure you write them down, so that way we can go over them in class.